Hello and welcome everyone to today's presentation about engineers in the workplace. My name is Paul Langedijk. I'm a chartered engineer with the ICE, otherwise known as the Institution of Civil Engineers. And today we've been asked by TENZ to give you a bit of an insight into what engineers actually do on a day-to-day basis. For that, I've brought in two of my colleagues from GHD Consulting Engineers, who will talk you through a recent project, one right in the heart of Wellington, the Jervois Quay Emergency Stormwater Works project. So there are two things we're going to go through today. First of all is the project itself and what you may have seen, how the project went, and some details around that. And then we'll go into what engineers actually do on a day-to-day basis and the different roles within this project. So first, I will hand over to James Mathews.
Yeah, cheers, Paul. I'm now going to quickly talk through a project that was quite popular here in Wellington in terms of it grabbed everyone's attention. So as the first slide laid out, I'm going to be talking about the Jervois Quay Emergency Stormwater Works. So as I'm sure a lot of you are aware that Jervois Quay is a 6-lane arterial road located in Wellington's central city. Now on average, 18,420 cars use this stretch of road. And it's also often used as an alternative to State Highway 2. So a lot of cars use this section of road. And that red dot there gives a quick or like a high level location of where all the works were occurring. So the problem was Jervois Quay collapsing. So on the 4th of February, a section of Jervois Quay southbound line began collapsing. 2 lanes were closed straight away, and this caused traffic delays up to 3 hours. So as soon as people were getting caused to be late home from work, it kind of grabbed Wellington's attention really quickly. So the problem, speculation began straight away. So as you can imagine, as soon as the road started collapsing, people were wondering what was the cause of this, what was some act of God or what was going on. So straight away, we got Wellington Water got out there and started cameraing the pipes. So digging at the location of the collapse found that this existing stormwater line had stormwater pipe had actually caused the collapse. So it was a 1920s pipe that had been left away from renewing for years due to the traffic issues of Jervois Quay. So getting to that pipe can often be really hard. And then additionally, as I'll show you in a second, the pipe itself was quite undersized. So that photo there gives a quite a good idea of how damaged the pipe was. So essentially, to create the collapse, when a pipe's cracked like that, water actually seeps out from outside the pipe. As it flows around the outside, it starts scouring away material and creates a bit of a void. So once there's a void between the pipe and the road itself, as cars drive over it, loading eventually bends the concrete or whatever seals on top and then creates a hole. So that's what actually happened at Jervois Quay to start it. So just to give you an idea of what the actual configuration or the pipe network looks like at Jervois Quay, it starts off as a 750, then transitions to a 450, then it stays at 450, and then eventually transitions to a 1200 where it discharges, which is a little bit interesting. So if you have any idea of or have any experience with stormwater pipes, typically the pipes start the smallest at the inlet point and then get larger and larger as it goes to the outlet as it picks up more stormwater. But in this instance, due to the fact that renewing a section across Jervois Quay is really difficult, it actually fell behind. So that's why there's a bigger pipe upstream of it and then a bigger pipe downstream of it. So it creates a bit of a choke point. So the solution, there's a photo of the traffic jams that were caused initially from Jervois Quay. So hopefully none of you guys got stuck in that. So essentially, fixing the problem while minimizing disruption to the public was the highest priority for Wellington Water, ourselves as GHD, and the contractors. So the preferred option was to open up the whole of Jervois Quay, all 6 lanes, and lay the pipe at one time. So to do this, you had to close all of Jervois Quay. So they found a date, which happened to be the Queen's birthday, where they'll close it for 4 days and then have contractors working over 24 hours fixing the pipe in one go. So that pretty much was a rip the band-aid off approach where they got all the works done without having to delay traffic for months and months with doing section by section. So to achieve this, Wellington Water ran a massive ad campaign to warn public of Jervois Quay. So you may have heard these updates on the radio, often on newspapers, even on the news. So it was pretty much just warning everyone, if you're staying in Wellington, try to avoid Jervois Quay over the Queen's birthday weekend. So the plan was to complete all the works in 4 different stages, but in particular, what we're going to be talking about is stage 2, which is a section crossing Jervois Quay. So the main design constraints that the engineers had to consider was that stage 1 had to be built in 4 days. Now, just to give you an idea, that the works were typically a section that long would take around 6 weeks. So 4 days is quite a condensed program. In terms of pumping, there was a lot of water in this area. So not only did you get water that comes down the stormwater pipe itself, but since the works were so close to the harbour, actual groundwater is a real issue. So as soon as you dig, that hole just fills up with water. So they were pumping 6.6 million litres per hour. So that's over 3 Olympic swimming pools of water every hour. And it had a fixed start and end point. So the pipe we were starting at, the starting point was fixed and the finishing point was fixed. So it made it really difficult when you had to deal with the jungle of services that ran across Jervois Quay, which I'm about to show you. So this is called a long section that pretty much shows all the services you've got to consider. The 3 main big ones is the chorus there. Those ducts are a lot bigger than they're shown there. They're about 2 meters by 1.5 meters in square, so they're really large. If you hit those, you're going to knock out everyone's internet, so people aren't going to be too happy. The next one is a gas main. As you can imagine, you don't want to be hitting gas pipes because suddenly the air gets filled with gas and then workers can't work. So that was another big one to avoid. But the biggest of all was the massive 800 mil bulk water main, which sits right in the middle. So that services pretty much all of the Wellington central city's water. So as soon as you knock that out, not many people are going to be getting water around Wellington, and people, as you can imagine, wouldn't be too happy. So how did it go? It was a bit of a huge success. So this is a quick time lapse that I'll play from Wellington Water. And I'm just kind of talking you through. So this kind of gives an idea of just how many contractors were actually working on the project. You can see there's trucks, there's excavators, there's concrete breakers. To do the works, most contractors here in Wellington don't really have 4 or 5 teams, and to do this over a 24-hour window, they wanted 3 teams working 8-hour shifts or 24 hours over 4 days. So to do this, there was quite a few different contractors from Wellington that typically work for Wellington Water that put their hands up, which was awesome because none of it would have been achieved without the guys on the ground actually doing all the works. As you can see, there's typically in each of one of these small screens, photo grabs taken on the time lapse. There's often 10, 15 people, but that doesn't actually give you an idea of how many were there. There were 40, 50 people on site at each time. So that's them finally sealing the road off, the pipe's been installed, and then everyone's back to normal, operating all 6 lanes. So yeah, it was a massive success, and what was completed over a short period of time was pretty phenomenal. So the results, as I said, Wellingtonians rejoice. So 6 weeks of work was completed in only 4 days. It has kind of created a potential new way of working in the central city. So this rip the band-aid off approach, where they'll get in, they'll close a whole road, and they'll just do all the works in one go without having to stop and start, open and close the road, and it ends up having more disruption than probably it would if we just closed it. Secondly, the ad campaign was a massive success. So the public praised Wellington Water for the extensive notification. It meant a lot of people they knew what they were doing in terms of they were just avoiding Jervois Quay where they could because they knew they'd get stuck in some traffic. And then ultimately, they renewed one of Wellington's most troubled pipes. So I'm going to now hand it over to Conor, who's going to talk about what engineers do at each level. So that's the client, the consultant, and the contractor. Cheers.
Thank you very much, James. That was great, really, really detailed, and gives us a good breakdown of what we actually did for this project. Now, as James said, I'm going to give a breakdown on who did what for the project. Client in this case was Wellington Water. The Wellington Water, as the client, they're responsible for all the projects in the areas of the local councils: wastewater, stormwater, and potable water. They have all the money, but they need the help from the contractors and the consultants to complete these projects. Consultant for this project was GHD, and Wellington Water approached GHD. Hey, we've got a big sinkhole in Jervois Quay. We need your help. Can you give us a cost estimate, a design, and a program? To which GHD says, no problem. As part of that, we worked as the project manager, the designer, provided an estimate and a program to complete the works before we handed it over to the contractor. The contractor for this project, Eddie Carson and Sons, were also approached by Wellington Water. Hey, we've got a big sinkhole in Jervois Quay. Can you fix it? GHD are working with it. Of course, ECS said back to Wellington Water, no hassle in the castle. GHD is sound bunch. So what we did then, we provided the drawings, the schedule, and the program for the works to Carson's, and they worked on that and submitted a price and a revised program to the consultant, GHD, and the client, Wellington Water. It's important, a little side note is that for this emergency project, we all worked very, very closely through all the different phases, and it was a great example of teamwork. Now, just to go into more detail of the roles. Client. What does the client actually do? And what does it mean? Well, the clients work closely with the councils and determine which projects are most urgent and critical, and so get the most money, and which ones don't. They are working with or for the councils, so which means they need to make sure that the truckloads of money that are putting into projects is being well spent. So they're involved at all stages of the project to assist us, offer advice, and to keep an eye on us to make sure we're not going off the rails. One of the key roles of the client is to inform the public, which means me, you, your teachers, your mum, your dad, your auntie, your uncle, your grandma, and everybody of what's actually happening, when it's going on, and what we are trying to achieve as the project team. As well as that, we have the consultant, GHD. What does the consultant actually do? Well, as I said, they manage a project, but managing a project doesn't give enough information. Well, the consultant is kind of like the middleman. We talk to everyone who's involved in the project. We plan the meetings. We work on the technical designs. We work on the communications. We also work on the project and the budgets. We work on the contractor claims. We worked on the contract for the project, and so on and so on. We do a lot of work. But designing the work is really fun and tough and challenging. We use information from 3D modeling, GIS information, site investigations using boreholes, and sometimes even just a quick sketch on a piece of paper, whatever we need to get the job done. We also are involved in construction monitoring, which means we work really, really closely with the contractors on the ground. We ask them some questions, that we answer some of their queries, and we make sure that the work is being done safe, correctly, and efficiently. Which brings us on to contractors. You've all seen contractors. Contractors are the guys and the women with their high-vis jackets at the side of the road looking into holes. In fairness, the consultants and the clients also do that. The contractors complete the hard physical work. They have excavators, dozers, scrapers, rollers, trucks, whackers, jackers, stackers. I just made them last two up. And they have all the other machinery required to get the work done. The contractors have site engineers, project engineers, and project managers for each project. And they work closely with the client and the consultants and the team on the ground. They're a very, very important role to ensure the work is going to design, highlight if there's any issues or problems, and to look after people's health, well-being, and safety. As well as the machinery, the contractors also bring the materials. That means the concrete pipes, that means the geofab, the environmental protection bunds, the fencing, etc., to most construction sites. There's other roles involved in construction as well and involved in this project. CAD drawing and computer visualization, for example. Have you ever seen this image here? This is how they used to do it back in the Stone Age. Warehouses-sized rooms of people bent over desks with pens and papers. Now we have modern 3D software and use BIM 360 cloud storage to work on amazingly complex designs to make sure that they're done with minor errors, minimal delays, and maximum safety. As well as that, we have surveying. These women and men are responsible for transferring the CAD drawings or 3D drawings onto the actual ground for the contractors to complete the work. They use really high-tech, sophisticated total stations that have laser-guided prisms that can be as accurate as 0.5 millimeters. Or they can actually just be a guy holding the staff in this photo here. It all depends on how accurate you need the project to be. If you're working on a nuclear power station, very accurate. If you're doing some landscaping in the back garden, you don't need to be that accurate. Moving on to the contract lawyers. The contract lawyers are responsible to make sure that the funds are being spent correctly as agreed between the client and the contractor. They'll make sure that money isn't falling into cracks and that everything is going fairly between the two parties. Health and safety. Health and safety have an extremely important role, if not probably one of the most important roles in a team. They're responsible for people, their lives, and their families. They helped us as on-site to stop, think, and reflect on a problem and think of it from a different point of view, as not just budget and not just efficiency or program, but to look at the safest way to make sure everyone gets home at the end of the day. Moving on to product manufacturing. Product manufacturing, this is everything from the 1.2 meter diameter pipes that James showed you earlier on, to the environmental nets, to the geofabric. All of this requires a team of people and engineers to produce this so that we, GHD, Carson's, and Wellington Water could use it on Jervois Quay. There are many more groups of people involved in the construction projects. I'd like to go into them more, but I just want to end on the professional institutions. Professional institutions hold presentations for the next generations of engineers, like this one, provide forums and space for us engineers to discuss issues and provide essential post-third level training and education to help us deal with real life problems that we face and can help us progress in our careers. Thank you very much for listening. I'll pass you over to Paul to finish up then our presentation.
Great. Thank you, Conor and James. Well, hopefully you've learned something today about what we do as engineers, and hopefully you can pass that energy on and start the future of engineering. So hopefully you are also as excited about engineering as we are. On behalf of the ICE, thank you very much for joining us, and we look forward to seeing you more in future as we work more with the TENZ. Thank you.